Okay, time for the mole. Now the mole in chemistry is in theory quite a simple concept, but in practice it's really quite difficult because the number that it equates to is really very, very large, but it is quite simple. Let's try and explain it as simply as we can. First off, the mole is the name we give to a number. Okay, we sometimes call this name the Avogadro constant because Avogadro came up with this idea. Okay, it's the name we give to a number. Now that's, I say, quite a simple concept because if I said to you dozen, you'd probably, hopefully, you'd be able to say straight back to me 12. The dozen is the name we give to the number 12. Within chemistry, the name we give to this number here, 6, with 23 zeros after it, that huge number there, writing it out in standard form, 6.02 times 10 to the 23. That number there has a name, and that name is the mole, or the Avogadro constant. But I know it's a huge number, but try and think of it like a dozen. If you think of it like a dozen, it's probably, hopefully we can make this a bit easier for you. You may say, well, what's the point of it? Well, let's not get too into that in this video, but let's just quickly say this. Atoms are really incredibly, infinitesimally tiny. So tiny we can't take one of them and put them on a set of scales and weigh it. But yet each of them have a mass number. Okay, and this I suppose is entirely theoretical if you're thinking about just one atom. So what Avogadro did was he worked out exactly how many helium atoms, say, we need to have 4 grams. So the mass number is 4. Well, how many atoms do we need to have 4 grams? It's going to be loads, isn't it? Well, it is loads. In fact, it is this number here. With this many helium atoms has a mass exactly of 4 grams. Okay, and it works out that the same for every element. So that many, 1 mole of carbon atoms weighs 12 grams. So the Avogadro constant, or the mole, takes these mass numbers, which are theoretical, and makes them something that we can weigh out on a balance. Now that's incredibly useful if we want to work out how much of a product is made in a reaction, or how much of a reactant is needed to make a certain amount of product. Okay, so it's a hugely useful concept, well worthwhile getting our heads around. Okay, let's see if we can do some questions around the mole. First off, how many eggs are there in a box containing 2 dozen? So 2 dozen eggs, how many eggs? And hopefully most people can tell me straight away the answer is 24. But of course, when I'm teaching, I don't let the students off the hook with that. I want to know what maths they did, and they look blankly at me for a moment. And I say, well, what did you do with these numbers, 2 and a dozen, to come up with 24? And after a while, they tell me, okay, it's 2 times 12, 2 times 12. That's the maths they did. Okay, so what they did here is we've taken the number of dozen, okay? We've taken the number of dozen, and we've multiplied it by the dozen, or the constant. I'm going to call it the constant. Okay? And that has told me the number of eggs. You may say, well, why am I writing all this out like this? Because it's a simple thing, and you all told me 24, and as I told you, this is in theory, these are very simple questions, but in practice, they're difficult because this number is so large. But this is the maths we did to tell us how many eggs there were in 2 dozen, the number of dozen multiplied by the constant. Over time, the eggs are used up. After a few days, only half a dozen eggs remain. How many eggs are left? So the number of dozen, this time it's half, so we need to put 0.5 in here. Okay, half a dozen. Now you're screaming at this now, it's 6, obviously. But we need to know how to do the maths because we've got much more complex numbers to deal with in a moment. So it's half a dozen multiplied by the constant, and the constant is, the dozen is 12, and the constant is given in the question for you. Okay, so half times 12, and that is 6 eggs. Okay, and that's what we're doing. That's what we're going to do in these next few questions. Okay, it doesn't get any harder than that, other than the fact we're using a slightly bigger number. I say slight, and that's obviously an understatement. There are 2 moles of water in a beaker. How many molecules are there in total? Okay, now most students, when I start asking that, go immediately blank, say, I haven't got a clue, and I say, well, how many eggs are there? If you've got 2 dozen, they go 24. This is the same. Okay, let's go back up here. The number of dozen. Well, we're not dealing with dozen anymore, we're dealing with moles. We've got 2 moles. So let's change this to number of moles. number of moles, okay, multiplied by the constant. Now the constant isn't 12 anymore, it's the Avogadro constant, the mole if you like, is 6.02 times 10 to the 23. And that's going to tell us the number of molecules, Okay, can you see this formula here is identical to this formula here? Okay, that's the formula we're going to use. Number of moles, 2 times the constant, 6.02 times 10 to the 23, 6.02 times 10 to the 23, okay, equals 1.204 times 10 to the 24, okay. Now, if you're good at standard form, you can almost certainly do that in your head exactly like I've just done it in my head. But let's just assume you're not, okay, because 99.9% of students I teach can't do that. But that's just because they haven't worked with standard form a lot. All it means is 6 with 23 zeros after it. Okay, so let's just forget that for a moment. And let's just assume, okay, let's just assume a mole is 6. The Avogadro constant is 6. 2 times 6 is 12, isn't it? Okay, so 2 times 6 is 12. 2 times 6.02, therefore, is going to be 12.04. Okay, and that's why we've got that there. Okay, we went from one number here to 2 numbers here, 12, 6 to 12. So that's why we've gone from 23 to 24. But anyway, that's to do it in your head. Let's do this in a calculator. I'd like you all to do this now. Okay, 2. Okay, so what I'm going to do up here is I'm going to do each of these. I'm going to put a box around every keystroke you're going to make on your calculator. 2 times 6, okay, decimal point, O. That was a 6 there, that's an O. 2. Okay, now this is the bit where everybody goes wrong. This is not a multiply sign. I know it looks like it, but it's not. Okay, on the calculator, normally the button's found down here. On this calculator, it's times 10 to the x, and this is a normal school issue calculator. Okay, if we go back to the last century when I was at school, go to my desk drawer. Here's my calculator I had when I was a spotty teenager. Okay, and the number here is this one, EXP. And I've seen that on a couple of calculators out in the classroom I teach in now. Sometimes calculators still have it as EXP. Do not use your iPhone to do this. Do not use your iPhone to do this. On the iPhone it's called EE, but you can't take your iPhone into the exam. What I want you to do here is use the calculator you're going to take into the exam, because you need to learn how to drive your calculator. That's vitally important. Okay, so it's this button here, times 10 to the x. Times 10 to the x. Then it's 2. And then it's 3, okay, and that's the 23 we've put in there. So 2 times 6, 6.002. That multiplied by there is times 10 to the x. 2, 2, 3, 3, and of course, don't forget the equals. And if we've got this right, and if I've got it right in my head, it's going to be 1.204 times 10 to the 24. Let's just get that down there so you can see it on the screen. Turn the calculator on. So it's 2 times 6.02. Now the all-important button, this button here, times 10 to the x, 2, 3 equals 1.204 times 10 to the 24. Okay, next one. Okay, I'm going to let you do that one. It's exactly the same as that. Okay, if you get the answer right, it's going to be about, I'm just not going to tell you exactly what it is, it's going to be about 3 times 10 to the 23. Okay, so you've got to do the working. I'm not happy with that answer. You need to tell me exactly what the answer is. You do it exactly like that. Same with this one here. 8 moles of sodium chloride. How many sodium ions are present? Exactly the same. Exactly the same is going to be 8 times 6.02 times 10 to the 23. Okay, and the answer is going to be about, let's think about that, 5 times 10 to the 24. It's not going to be exactly that. Okay, it's about that. I want you to tell me exactly what it is. Okay, now another one. In another pot of salt, there are 1.3846 times 10 to the 23 ions of sodium. How many moles are present? Okay, well this question is different now, isn't it? It's different to the other ones. Okay, but it's no harder than saying, I've got 36 eggs. How many dozen do I have? I've got 36 eggs. How many dozen do I have? Okay, 36 eggs, how many dozen? Well, hopefully you're telling me it's 3 dozen. 1 dozen is 12, 2 dozen is 24, 3 dozen is 36. You could work it out like that, I suppose. Okay, but what's the maths we did? We've got 36 eggs. How many dozen? Well, we did the number of eggs. Okay, so in this case, we're going to have number of particles, whether it be ions or molecules or atoms. Okay, we did number of eggs 36, didn't we? We did 36, and we divided it by the constant 12. We divided by the constant, so we're going to do number of particles divided by the constant. Okay, 36 eggs divided by 12 is 3 dozen. 36 eggs is 3 dozen. Okay, so that's going to give us the answer here. So 1.3846 times 10 to the 23 divided by the Avogadro constant, 6.02 times 10 to the 23. Okay, now if you do that, and you're going to do it again, I'm going to give you the answer to this one. It's going to be about 0.25. It's going to be about a quarter. It's not a quarter. It's going to be about that. Okay, next question. Now they start to get really quite nasty. If you're doing these, you're working at GCSE grade 9 standard. Okay, these are invariably the questions they put right at the end of the paper. Not difficult, theoretically, okay, but in practice they are, because the numbers are just mind-blowing, aren't they? This number is mind-blowing. Okay, so if you're finding it a little bit tough going, it's supposed to be. These are really, really difficult. How many atoms are present in 2 moles of hydrogen gas? Okay, well, 1 mole, okay, 6.02 times 10 to the 23. Are we happy with that? 2 moles, yeah, equals 2 times 6.02 times 10 to the 23. All right, we happy with that? Stick that in a calculator. 1.204 times 10 to the 24. Okay, there's that many molecules in 2 moles. Okay, but this question doesn't ask how many molecules in 2 moles. And this is the fly in the ointment. This question relies on you knowing the difference between a molecule and an atom. This question asks how many atoms. Well, 1 molecule of H2 looks like this. Hydrogen bonded to hydrogen. There's 1 molecule of H2. And look, it has 2 hydrogen atoms. That's a hydrogen atom, H atom. And there's another hydrogen atom. So, 2 moles of hydrogen, okay, contain 1.204 times 10 to the 24 molecules. But every molecule has 2 hydrogen atoms in it. So we need to take that number, 1.204 times 10 to the 24, and multiply it by 2 again. And that will now tell us how many atoms. Well, you can do that. And the answer is going to be, what's the answer going to be? It's going to be about 2.5 times 10 to the 24. Not exact. You need to work it out. So every one of those, I'm going to box up on this page now. Okay, these are not exact answers. You need to figure them out. Now you can show me in class. If you don't have the misfortune of being taught by me, then show them to the teacher, whoever's teaching you, and just check they are right. Because I am more interested in your working than I am in the answer. Okay, the working is the crucial bit. All right, good luck with that.